motion demonstration to explore wave properties of speed, frequency, and wavelength. My name is Jeff Burbank, and I'll describe the motion. Then Mr. Helms is working on the left side of the demonstration, and Ms. Clounch is working on the right side. On the right side, Ms. Clounch will use her thumb wrapped with fluorescent tape as the oscillating source of a wave that will move through the yellow spot medium. This wave pulse is a single oscillation moving through the yellow dot medium at constant speed. When the wave pulse reaches the other end of the medium, it reverses direction. This is reflection. Now, a wave consisting of a series of crests and troughs moves through the medium at constant speed. But notice that the yellow dot medium itself isn't going anywhere. Now on the left side, Mr. Helms is connecting a mechanical oscillator to the yellow dot medium. This oscillating source will create a wave moving in the opposite direction. We can call this the high frequency oscillation, and you can see for yourself how frequently it is vibrating. If anyone is counting, it's making 6 complete vibrations every 4 seconds. The frequency of the wave produced by the oscillations is the same as the oscillator's frequency. The distance between the adjacent wave crests corresponds to wavelength. Alternatively, wavelength is also the distance between the adjacent troughs. We have a meter stick positioned with evenly spaced tape marks under the wave. For this high frequency oscillation, you can see the crest popping up above each tape mark. You notice we turned the oscillator off a little too quickly here. If someone has really good vision, they could read the meter stick and see the distance is 35 centimeters. This is the low frequency oscillation, and you can see for yourself that it's vibrating less frequently than the previous oscillation. If anyone is counting, it's vibrating 3 times every 4 seconds, half the frequency of the previous oscillation. For this low frequency oscillation, you can see crests pop up at the 2 tape marks at each end of the meter stick. And when this happens, there's a trough located in the middle tape of the tape marks. Similarly, when adjacent troughs descend toward the end tape marks, there's a crest at the middle tape mark. So the distance between the 2 end tape marks corresponds to wavelength. With really good vision, you'd see that this distance is 70 centimeters. So we have demonstrated waves created by oscillation. The high frequency oscillation created a wave with a short wavelength. Then the low frequency oscillation created a wave with longer wavelength. In fact, the second oscillation had half the frequency of the first and created a wave with twice the wavelength of the first. This concludes our demonstration.